This is Dan Walsh, also well known for SELinux, and Josh Bressers, and I'm going to let them introduce themselves, and then we will take questions.
Okay, I'm Dan Walsh. I've been working on the SELinux project forever, basically, and I'm kind of a security evangelist for Red Hat. I actually blog at danwalsh.livejournal.com, new security features in Fedora. Usually every Fedora I try to put out approximately 10 new security features and study what's going on in the security world. I'm a big proponent of turning on security, obviously, and we'll talk about that. But and my talk on this is going to be more about how to take advantage of some of the security tools that are available on in the Linux operating system.
Hello, my name is Josh Bressers. I run what's called the Red Hat Product Security Team. And what we do is we're putting a lot of focus inside Red Hat at the moment. We're working on sort of the whole secure development concept at Red Hat. And as you can imagine, that one of our challenges is taking what's happening outside in the open source universe and somehow adapting that, and additionally working with upstreams and in Red Hat and all kinds of things. We run securityblog.redhat.com as kind of our big claim to fame at the moment externally. And we have a number of projects that we're working on to sort of start evangelizing things outside of Red Hat. But for the moment, we're basically doing a number of secure development things inside the company and not a ton of work outside right now. So.
All right, so generally speaking, because it's kind of a panel, we're going to take questions from the audience. If you don't have a lot of questions, then I will also be asking questions. So does anybody have anything that they'd like to talk about in particular? To start off with? We have no secure development crickets. All right, go ahead, shoot.
As you take your open source projects and you migrate them into hopefully some kind of standardized packages that Red Hat supports, how do you affirm a certain level of security and stability and kind of verify that you're not taking in code that's untrusted into a trusted code base?
Well, that is, I would say, a very good question. So, kind of the, how do we ensure basically that something we're getting from upstream is something that we want to deliver to our customers, right?
Yeah.
From a security perspective. So, Josh, I'm gonna ask you to at least start to answer that.
Right, the answer is magic. So we do a number of things at Red Hat actually in that respect. Is the most important thing we do, and I encourage this for all of you who sort of run anything not from Red Hat from upstream, is get involved. There are a lot of projects we're involved with the upstreams, and so we have a very good concept of what's happening there. But basically what happens then is we take the packages from upstream, and of course hopefully they have things like digital signatures. We can verify that what we're getting from them is what they put out there. Because instances arise where the bad guys will replace packages on one mirror, we'll say, but not everything. And something like the digital signature and checking the checksums and stuff like that will catch that. So we take things, we bring it in-house, and then we do a certain amount of automated inspection, and we do a certain amount of manual inspection. We have some people who physically look for potential security problems in this stuff. That's generally done with the big Red Hat, the major revs we have of our stuff. And then obviously we have our QA that does the testing and whatnot on the products and kind of just making sure everything looks good. And so far to date, we've not had any issues with that, and we're fairly meticulous, so I won't say it will never happen, but we're definitely working very hard to make sure it doesn't.
We also have static analysis tools that go through the code. And for the real major sections of the operating system, Red Hat obviously likes to put our engineers as major contributors and major influencers of sections, so that we usually have someone at Red Hat that's very intimate with the code, and we're not taking in sort of random. In Fedora, there's 85 billion packages. In RHEL, there's a lot less, and there's a reason for that. And secondly, we also have a security response team that is out there, and actually one of the members over here, and their job is sort of to monitor what the white hats and the black hats are talking about, and everybody knows what a white hat and a black hat is. Basically, a white hat is a hacker that looks for vulnerabilities and then tells the companies about it, and a black hat is the person who looks for vulnerabilities and then tries to make profit off them or do something evil with them. But the nice thing is both of them like to talk, so and you just monitor them, and then so there's actually conferences where they get together and stuff, and we have Red Hat people that are always involved in that, as well as the rest of the open source community. So usually when a vulnerability or something like that happens, there's chatter about it, we find out about it and fix it. Do you agree with that somewhat?
Well, and actually, just kind of also to add to that, right, is I think the kind of default, answer to that question a lot of the time is lots and lots of code review. And I think what you're hearing from these answers, right, is that being involved in the groups that are producing this environment, as well as kind of being involved in the general security community, makes a big difference. So also kind of knowing what's out there and what's going on. And being involved in an open source project doesn't necessarily mean just contributing code, right? It means kind of reading the mailing list, looking at the documentation, knowing what's going on. Because if you're just actually looking at the code, the likelihood that you miss something is pretty high, right? So you've really got to kind of look at the thing holistically, kind of in general.
And just to give we have this unbelievable tool that affects code to watch when it does stuff that is really stupid. It's called SELinux. and we see lots and lots of random ABCs, and then we go back to usually it's not some evil person doing it, it's just a coder doing something that is totally off the wall. And so, SELinux actually does reveal lots and lots of bugs in code, or at least design choices that I find questionable. So, we do obviously try to wrap all this code with something that's from a security person that's looking at it and saying, well, that code really should just do this, and all of a sudden it starts doing something random.
Did you have a follow-up question?
Yeah, just really small follow-up question then. You just mentioned if something does slip through, what is your reaction process to pushing out a bug fix, or at least certifying that bug fix, or how it happens in your release cycle?
We have as I said earlier, we have a security response team that has some really brilliant people, and when they see these problems, either they find a fix, we get a fix from the upstream community, and our goal is, I think, 24 hours to
well, it depends what the severity is.
Yes, yeah.
I mean, for critical things, like if we found a backdoor, yeah, we'd get that fix out. It absolutely, people wouldn't sleep for days to make sure it happened.
Thank you. Well,
there was a kernel vulnerability a couple of weeks ago that was pretty huge, and all of Red Hat just, all the people involved in it just
paused.
Go into rapid triage. It's just too critical to let something like that.
Well, and I think there's kind of a well-published protocol that we respond with, but I think one of the important things to kind of take away is that, to the best of my knowledge, basically never do we not have that bug fix kind of going to upstream. So, which I think is kind of interesting, right, with kind of working with Red Hat, so that it's not only in our products, right, but everybody else benefits from it as well. Usually right around the same time, not always. I don't know if it's sometimes it's critical to get out right now, right? But did you have?
I guess my question is, I don't know, maybe it's facetious, I don't know. Given the number of vulnerabilities reports that I see or go past my customer's desk anyways, is this a solvable problem?
We just got the humans out of the business.
Right.
Yeah.
When the
problem
machines take over.
keyboard and back of chair.
Well, I mean, I've heard rumors about my customers saying they're going to get rid of all of open source.
Well, it's
of
not
course,
just,
go to all Windows, that's even worse. But
yeah,
but
I can sort of address this. The question is basically, with the number of security flaws you see, is this a solvable problem? And the answer is no. It is no. And it will probably never, there are always, as long as human beings write software, there's going to be bugs in it. And some of those bugs, like bad guys do bad things, basically. That's a security bug. Now, The problem we suffer from in the land of open source is the emperor's naked, so to speak. You know, if we can't sneak bug fixes in. And various closed source competitors of ours, we'll say, have been caught numerous times, and they freely admit that if they're fixing, say, an important security issue in this component, and they also found 30 moderate issues, we'll say, or low severity, something important or less, right? They will just not talk about it, because why bother? There's already something worse, so people are, if they don't care about this, they're going to care about the, you know, all that other stuff that we found as well. And so that, kind of from a PR perspective, damages open source, because it makes us look worse, statistically speaking. But in reality, I'm quite skeptical that we're any worse. I personally would like to say we're better, but obviously I can't back that up with any sort of facts. Right, yes. So I conclude. But it's never going to go away, but there's some things we can work on to sort of try to make it less of a problem, you could say. You know, things like Dan's work on SELinux. SELinux is a huge thing. If you turn that on, that can eliminate, you know, all kinds of issues you could potentially have. There's work Red Hat's doing with things like the compiler and the libc libraries and things like that, where if we enable some of these technologies, we can eliminate certain issues. One of my favorite examples is GCC has something called Stack Protector built into it now, where if you turn this on, the whole stack buffer overflow thing that was, you know, everyone remembers those from some years back, that problem's basically eliminated. You know, it's not always eliminated, but for the most part, it's gone. And so things like that are really where it's at. It's that we can't fix people necessarily. The thing I like to tell people is I can train out the stupid, but people are still going to make mistakes. You know, we can stop stupid mistakes, but we can't stop all mistakes. But tools can hopefully catch many of the other mistakes that still exist.
Well, I think the other thing too is that kind of the driving complexity, right? Is that, you know, every time a new cool framework comes along, right? It's just more of a stack of code, right? That is just more lines for, you know, for there to be, right? And then, you know, kind of our app sits kind of way up here, right? And just the more lines of code in there, the more features we get and everything else. Even if they're all people involved are excellent programmers, which, you know, they aren't always, right? It's just an increased possibility for mistakes. It's just, you know, statistically, you have a mistake 1 every 100 lines of code, it just goes up. So I think that it's never going to end. I think there's kind of 2 parts in it, right? So, you know, we need to make sure that more people know how to write good, secure code. But then I think we also all need to commit to kind of using the tools all the time, you know, like the SELinuxes of the world. And if it's blocking us from doing something, then we need to fix it, you know, not turn off SELinux, right? Sorry, we had a question in the back.
How does common criteria affect how you guys work?
So can you explain the question first? Does everyone know
Yeah,
common criteria?
a common criteria is a set of standards that the government has written over the years to basically define how a computer system should work. And then you, so for instance, Red Hat and RHEL 5 has multiple common criteria certifications that says that we meet these government criteria for how to run a system. The most common one is this thing called CAP, which basically defines how you should set up how many, you know, what protections of directories and files, and which applications can get more privileges and things like that. So common criteria tends to keep us honest, and the nice thing about common criteria is the third party that comes in and analyzes. It's not Red Hat coming in and saying, wait, we're common criteria. There's actually third parties that come in and actually study the code, look at design documents, and verify that we're following to the different standards. Now, there's in Red Hat we actually have common criteria to the set of the CAP, which is the sort of the standard Unix protection system. Then there's another one called LSPP, which is a mechanism for storing top secret type data, data at different sensitivity levels. We have that on RHEL 5 and RHEL 6. And now there's new ones being developed for virtualization and how do you control what the virtual machines are able to do on it, and that's called BSVP. So basically, the nice thing about these government, it gives us a goal as distribution providers to match these things. And we actually are forced by the people doing the analysis of our code to actually modify the code and you know, to meet the government, you know, the government's certifications. And some of these certifications, you know, we can't even meet because it's so high up that, so that you'll see different levels of certification. But Red Hat, we do a pretty good job of meeting these, and that helps us, you know, obviously make the code more secure. I think we got a question. Yeah.
I'm just curious on a specific class of vulnerability. For better or for worse, I always seem to see memory safety issues, whether it's use after free or use after free.
Right.
In any kind of C, whatever, it's a browser, Java, otherwise it's always use after free. Is there a magic bullet, as it were, how you can insulate users, Red Hat users, whether it's SELinux, a web application file, or otherwise from that?
There's more of security in depth on that type. I mean, first of all, the GCC compilers start to do a better job of detecting these
Yeah.
tools and preventing them. Also preventing, you know, after you have this, you basically need to get to a buffer overflow or some way of writing your code into the executable stack and then executing your code. So there is, SELinux has 4 different protections against this type of attack. The problem is there's so much code that requires these extensions, the exec map, exec heap, exec stack. So most of our confined applications aren't allowed to do it. The problem with SELinux is that user space, users don't like to be confined. So if you're going in, you're running a shell script or whatever, so we have to turn down a lot of the security. And there's a lot of the newer technologies now are requiring it, so just-in-time compilers, Java, Mono, all need basically executable, writable memory. So it's a sort of a battle between best security practices and sort of the latest technology.
Yeah.
So you know, and I'm always battling back and forth on that, and you know, I can't, you know, if I with SELinux, I can turn up the security really high, and then everybody turns SELinux off. So I have to find this sort of a happy ground for that type of protection. But we're working all the time, as he said, on the Stack Overflow checks. There's lots and lots of neat new things that are going into the compiler, but even in that case, we're battling the fact that if we put too many checks into we start to slow down the applications, and then we have someone from, you know, the funny thing is, most companies that transfer the most money want the least amount of security because they're not willing to pay for any, you know, CPU.
Sure.
You know, because the stock market has to try to trade them. So we always have to balance out that equation too. It's like, you know, if we turn up the security too much, the system slows down, and people turn up the security.
So I just wanted to add, so Josh, can you talk a little bit about experience with having to balance security versus kind of application needs?
Yeah. So, I mean, this is a good example because there are libraries that will stop this now, but they're extremely expensive to use. So no one does.
Yeah.
Because they just eat a ton of processing power because they basically re-verify all your RAM constantly. You know, as for getting rid of them, I'm hopeful that someday we will through some sort of advanced research that we just don't know about yet. You know, we're always, the bad guys continue to research new ways to break things, and the good guys are always looking for ways to stop that. And the best way is obviously to just completely eliminate classifications of flaws, not to keep band-aiding things as you go. And so, you know, picking on this example some more on this is how we can do that. You know, I know of people looking into some of this stuff, trying to think about what can we do. You know, are there some tricks we can use with existing hardware? It's possible that with our existing hardware today we can't. I mean, things like non-executable stacks, for example. That's relatively new technology in the scheme of things because this was really added fairly late in the game in the x86 universe. But at the same time, it makes a huge difference, you know, being able to mark memory as non-executable. And that's also one of those changes that we get for free, you know, basically, where we aren't it's not costing us CPU time or memory to do this sort of thing. And I suspect that as we continue to evolve our hardware and software, we're going to see more and more of that, where things might start out as an expensive sort of task, but then as hardware manufacturers get on board and we just understand the problem better, you know, as a software creators, that we can kind of work to eliminate some of those hang-ups. Make sense?
Yep. We've talked about some libraries and processes at SELinux to help mitigate risk by these vulnerabilities, and also how to manage open source. I'm curious how these new features and advances in technology or support for vulnerabilities or vulnerability fixes kind of is supported across the range of Red Hat versions and support for if I were to be on old, say 6.1 versus 6.4 of Red Hat Enterprise Linux, what would be kind of my increased risk, or would there be any increased risk? Like, do you push your security mitigation techniques across your versions, or do you support new features and new versions of Red Hat?
I think major versions, we add new security features. We don't tend to do them on minor versions. There's two reasons for that. One is we don't want to break anything.
Right.
So from an SELinux point of view, I never push new confinement out, because if you go from 6.3 to 6.4 and all of a sudden your Apache server starts blowing up, you know, you're not going to be very happy. So it's very different. And secondly, there's advances in the kernel, but the kernel has ABI changes, and Red Hat has a guarantee that we don't change the ABI of the kernel. So when we come out, as a matter of fact, next year at the summit, I'm hoping to have a hour-long talk that just talks about all the new security features that are in RHEL 7, which would be brand spanking new. Those features are most likely never going to show up in RHEL 6, and definitely never going to show up in RHEL 5. But you know, we're always putting security fixes back, but we're not putting new security measures back.
Right.
It's pretty rare. I know we backported a double free mitigation at one point. I think that was, I want to say, was it RHEL 4 we put that in? Do you know?
It was RHEL 4.
Was it RHEL 4? Okay.
Yep, I found it.
Oh, nice. But even then, I mean, that's an instance where by adding this, even though you're talking about a bug essentially, it's going to break something from someone because they're running a buggy application essentially. And
Or they have workaround, right? Or they're leveraging the bug, right? There's, you know, you do a lot of crazy things when you're programming, because, you know, at least in the programming I've done, I'm sure this isn't true for anybody else, usually there's not enough time, zero requirements, and you know, you've got to get something out the door. So I think you got to be really careful, even quote unquote fixing a bug, because you never know how you're going to affect the workarounds that people did around the bug, you know, or leveraging the bug.
Yeah.
Just a small follow-up then. So then, if I were to deploy an infrastructure, for example, cloud computing infrastructure, then there would be a need to stay ahead of the deployment curve, right? I can no longer rely on the legacy infrastructure. I have to always migrate to the newest version to stay ahead of that security curve.
I'm not sure why. I'm not getting the correlation that you're making.
Sorry. So to leverage, of course, if I have an infrastructure, I have to plan when I deploy new versions of Red Hat, for example, Red Hat 7, to leverage those new features. But if there's a vulnerability, if I deploy to cloud on 6, then I would have to analyze the cost of upgrading.
It's the same exact problem as in your data center.
Yeah.
There's no real change there. I mean,
You know, I
if you really
noticed-
wanted to, you run your applications on Windows 3.1 in the cloud.
Right.
You know, I've got a couple of, you know, but I mean, usually, depending on the cloud provider, right, usually they're not forcing you to upgrade. I think the question does actually start to get interesting when you talk about something like OpenShift,
Yeah,
right?
that's
Where you get automatic upgrades,
Right.
and now what does that mean for you, right? So, you know, like what happens when if you're deployed on any kind of pass, right? It's not just OpenShift. That means that you are getting upgraded versions of stuff underneath you all the time. So if you have workarounds for bugs, or you have workarounds for security issues, or you have just, you know, your plain old code, that can have some interesting side effects.
Yeah, I mean, he brings up one of the things that actually he just brought up is we are starting to backport applications to full application stacks to older versions of RHEL. So you can get the latest GCC, you can get the latest Python, the latest Ruby, and that actually plugs right into what he talks about. But so we are moving some of those things back. It's more about like I mean, the latest kernels in Fedora right now have some really neat security features that we can't really get them to work in a RHEL 5 box.
But actually, I mean,
without breaking something else, obviously.
But that is actually, I mean, that's kind of, so software collections is kind of that upstream stuff, of like the style of how we're delivering like Ruby and stuff like that. And part of what we're doing there is essentially, like what I refer to as a sideways install of like Ruby. So Ruby's got a native, that comes with the distro, and then you can get a software collection of Ruby that installs separately. It's completely unrelated. So that way, if you're, running your app on Windows 3.1 and you want to put Ruby on top of it, first of all, you have to figure out how to port it to Windows, but then you don't actually affect anything about your running application. You can choose whether or not you install it, and then for every individual application case. Unlike, where, in RHEL 5, we all of a sudden just kind of push in a bunch of new SELinux policies that just show up for everybody, right? So that way we can kind of try to get some of that balance.
Yes.
Oh wait, hold on just a sec. Anybody over here? We've only had questions from this side of the room, except for the guy right there. So anybody over here have a question? Nothing? Really? Come on. All right. So then we'll have you ask your question. Or maybe you can go sit over there and ask it.
This is security. This is supposed to be security and software development. So can you describe the role of SELinux in software development and what developers need to be aware of that they're developing in that environment?
I actually have some slides right in front of me because I have a very bad memory. When it comes to, well, first of all, I always yell at, I hate anybody that gives me an application that can be installed anywhere, and the user goes in and chooses his ports, and he chooses where his content's going to be. It's like, that's the job of a developer, is to choose those things. Now, it'd be best to use LSB, choose the logical places for this content to go, and just make it happen. So, don't have a user come in and say, what port do you want this thing to listen on? Go register your port, and then SELinux can come in and say, my application foobar has a foobar port, 3252, and then we just go in and write the code. Because frankly, administrators don't want to make the choice. Users don't want to make the choice. You make the choice for them, and then it becomes standardization. I've been in a war with the /temp forever. Okay, /temp. Anybody that writes a privileged application that uses /temp, I want to kill. There are places on the system. /run is the place in a modern RHEL systems. /run and run. /run the same thing at this point. But a privileged process should use /run. I watch the OS security list that comes out all the time. The most common vulnerability that comes out is people using a guessable /temp entry for a privileged process. So, just if we could just get people to /temp is for users. If I'm not a user, then I use /run.
Now I'm going to pick on this point though, because that's never going to happen. The correct solution isn't to teach people not to use /temp, it's to make that problem go away. And we actually have a solution to that, which is basically every user gets their own temp, poly-instantiated temporary directories. And it's being worked on. There's still some issues we're working out, but I mean, that's the solution, because Dan's going to be dead long before people stop writing stuff in the temp. And that's just the sad fact that we have to deal with.
So actually, in RHEL 7, System D has a new feature that individual services have their own /temp. So for instance, Apache's the biggest. It's not Apache, it's like everybody writes code that's going to run inside of Apache, or PHP scripts, things like that, and they're all using /temp, because /temp's where you put temporary files. So now in RHEL 7, and in current Fedoras, Apache has its own /temp that users can't get to, so that it's different. The problem with doing this is it becomes, human beings have a hard time understanding that paths for one process is different than a path for a different process. So I put something into /temp, then I go into root and I look in /temp and it ain't there.
You get a little confused.
You get confused. But yeah, but out of default, put your stuff in /run. SELinux likes, and it's modularity. So when I'm doing coding, when I'm writing code, smaller apps are better than big apps. So doing your Microsoft Office that can do everything on the planet versus having little tiny applications that Microsoft Office takes advantage of. From an SELinux point of view, we control at the process level. So if we can wrap individual processes and say this process is going to do only this activity, but if your process has to do everything, then so I mean, this is one of the problems with like JBoss. SELinux can really not control what JBoss can do because JBoss is all running in a single session. So we have to rely on different tools for controlling that.
Is that true though? That's also true in a sense for any VM language, right?
Yeah, any huge monolithic type application that runs thousands of threads in single processes we can control it. We can control it at the external level. It says what this application can do. So usually we're controlling, say, the Apache process and it's running JBoss. So we can control at that level. We can't control if your account credit card data stored mechanism is in the same process as the one that's listening for packets coming in from the internet. We really can't separate them very well. Okay. One thing that's coming, and actually /temp has talked about it a little bit, is this thing called namespaces. Namespaces, most people understand LXC or containers, and we're giving it. There's a talk at the summit I'm giving on Wednesday on new container technology that's we're now implementing inside of RHEL 6 and mainly in RHEL 7, and it starts to get you the ability to take an application and sort of change its worldview. So like the /temp, but doing additional type of separation. And you can start to get towards sort of a virtualized environment, so your application lives in its own little sandbox area. So if you start to wrap applications in multi-levels of security, so you have a containerized environment, you have SELinux, there's other tools that are arriving. So really what we want to do is have multiple fences for the hacker to have to jump over. Or if you can get, the ideal thing is to run your entire process staying in a virtual machine. So now the virtual machine is protected, the host is protected from the virtual machine if that's running a single application. So start to put as many layers as possible between that your application has to break through.
Do you have another question? Or
Sadly, yes.
yeah. Anybody over here again? Check it out. All right, go ahead.
It's just I'm actually building, my question was somewhat related to what you were saying. So if I were to have like the JVM or a hypervisor or something like that, how does SELinux play a role in managing those kind of hypervisor related processes?
Yeah, I mean, one of the biggest advances that SELinux over the last few years is this idea of, it sort of coincides with the way the industry is going, which is what I call multi-tenancy. So multi-tenant environments is where you have hundreds of thousands of processes that all basically are doing the same thing. So OpenShift is classic example, right? We have 150,000 user processes on the computer system. So how do we isolate them? One of the things we developed about 4 or 5 years ago was this thing called SELinux MCS policy, multi-category security. And what we provided to is secure virtualizations, SVR. So when you launch a virtual machine with SELinux RHEL system, it actually picks out a random SELinux label and applies it to both the virtual machine and its content. And now if the virtual machine, if there was a hypervisor vulnerability that an application could break out of a virtual machine and attack the host, SELinux is actually watching the process and basically says, hey, you're a virtual machine, you're only able to touch your virtual image, you're not able to touch other parts of the system. So similarly, we're doing the same types of things with OpenShift, we're doing the same things with new secure containers.
Yep.
Hmm?
So like there's a lot of Java vulnerabilities these days. So how does it play with?
Well, I mean, the Java vulnerability, again, we would lock you into your Java app. So that even though, I mean, I'll be doing demos this week of processes running as root on the system and only able to do, an OpenShift process running as root is only able to touch the OpenShift directory that it's allowed to write to. So most people, when they think of vulnerabilities, think of a process getting privileged escalation to root capabilities and how do we control that. And that's really what SELinux shines at doing.
Yeah, I mean, it kind of goes back to, I think what we're starting to see a lot of the time, kind of as developers, is starting to think about how do we essentially run our application almost on an individual machine. And that machine, actually, I think one of the nice ways of doing that is like with containers, because it's got a lot less overhead. But I don't know about you, but I've been programming for years now on VMs running on my laptop, right? So every application I work on gets its own VM, and then I kind of work on it there so that I know its kind of environment, right? I know, for example, what SELinux policies are on. I know what firewall setup is set up. I know what languages are installed and all that, so that when I want to deploy it someday, I've got a lot more control of the environment to do that from. Go ahead.
Just from a secure coding perspective, whether it's Eclipse or an IDE or VI or Emacs, what are the best practices that you're typically telling?
Emacs, just use Emacs.
Just use Emacs and leave VI alone.
Except when you need VI.
Till carpal tunnel description. Yeah.
I don't know if there's necessarily an answer to that. I think the key is really just consistency, making sure your team, because obviously no one develops in a bubble anymore.
Sure.
It's always teams. And just make sure everyone's using the same tools. That way, when someone does their builds, that you've got the same flags and the same warnings, and people are seeing the same environments and all that. Because it's sort of one of those instances where I've seen problems before where one guy might have had warnings turned on and the other guy decided not to turn warnings on for the compiler and causes trouble.
Yeah.
This is actually where I also get into, and so we're going to also have kind of this DevOps track, right? And we talk about that kind of models. One of the things that is kind of not often talked about with DevOps is that one of the things it can do is it starts to take a more holistic view of the kind of life cycle of code, build, QA, deploy, such that it's kind of one automated process. So even if you're not doing like continuous deployment, but you're still doing some level of continuous integration or essentially build engine stuff. What that also does, if it's directly integrated into the developer's coding environment, is that it makes it so that everyone is using the same one, which can make a big difference. The other thing that I've also done as a team lead a lot of the time is I will build the VM that everyone will use to do development on. And then I actually just essentially ship the VM to the team. And it can start to vary a little bit, but that also I think makes a big difference.
Yeah. I think, again, one of the things that programmers don't take enough advantage of is the power of the compiler to find problems. And you can dial up the compiler to a level of trying to think of a non-swear word, but so it's not so anal that it'll drive you out of your mind. But once you get over the hump of like all warnings are errors, so the code just blows up. But just find out the latest security flags that are built into the kernel, to the compiler, and just turn them on and force your programmers to say. There's too many programmers that just say, they run this script and you'll find 4,000 warnings flying across as the code compiles. So at Red Hat, we tend to try to crank those things up as high as possible. There's lots of great engineers working on these compilers to look for problems, and just crank up the security as high as you can and get.
Do things like Python, Ruby, do those type of languages do that?
There are tools to analyze your. I'm not sure. I'm not a Ruby, but there is Python code.
There's a lot of things like kind of the linked variants. There's the Java one too. There's a code checker that has also made the rounds. It's been like reported to all the other languages too. So there are. The problem is that the experience with like compiler flag warnings is even worse because you can completely circumvent the tool chain if you so desire. Whereas like the compiler, you kind of have to be making a choice to turn them off. When you're using kind of an external tool, it's a little harder. But that's in some ways, particularly in big development enterprise environments, that's actually one big reason to encourage the use of IDEs, like Eclipse, because then you can actually have, like, everybody has Eclipse installed, then you can actually have centrally managed, kind of plugins for Eclipse, and then you can kind of, as an enforcement policy, in a sense, they can still get around it if they want to, but at least you're shipping down to everybody kind of the tool chain and making sure that all that stuff is turned on. So that can help. Doesn't always do the trick, but at least you're again forcing the developer to make a choice, which I think helps.
So at Red Hat, we're actually using some continuous integration technology to do exactly that with like Ruby and Python and stuff.
Every year he comes here, he gets sick.
I do.
Yeah.
It's terrible.
I think he's allergic to Red Hat Summit.
Or Boston.
Or Boston.
Yeah.
Maybe me.
Yeah,
Most
sorry,
likely.
that's all I had though.
Still no one on that side?
I don't want to raise my.
Oh, we got
yes!
one! Hey! Yeah, let me give him something.
So Java's kind of gaining a lot of popularity. Is Red Hat looking at getting some more of the static analysis tools to build into RHEL for Java? Something like find bugs or anything like that?
Here's your present for asking questions.
Oh, thanks. See, you should have come over here early.
I bet he's got enough for everybody,
Yeah,
although we
most
don't
likely.
mention it. So static analysis tools for Java, are those, if they're on the like doc, are there not any in RHEL now?
We had someone that was going to sit right here that could answer that question.
Yeah.
He's
He had
in
some
jet
travel
fun right now.
problems.
What
So
about your work or no, the developer tool sets?
yeah, so there's not any. There are static analysis tools there, but not Java ones.
I was
So
going to say, if there is one, please tell me.
so developer toolset, the beta version, so the 2.0, which is in beta, whatever, last week or something, has some static analysis tools. I'm gonna look at Brian and see if you can tell me which one's off the top of your head. Yeah, isn't there a new static analysis tool in there? Oh, profile. Yeah, so some of them are in there, but they're not Java ones, they're C ones.
Yeah.
But if you at least it's a start because you can do static analysis on Java, right? So that was a bust for our ability to answer said question. Are there any other questions? We're almost out. Go ahead.
When new vulnerabilities come out for the various interpretive web languages, like people all yell things like, hurry up, migrate to the fix. It's like, well, we got to test it, regression, and all these things.
Yeah, you don't need that.
Yeah,
Well,
but we mandate SELinux is on and running on all the systems that are publicly facing. But the vulnerability announcements sort of never say whether or not I'm immune with my angry SELinux policy turned all the way on. Is there any way we can get some of that information?
wait, I'm not sure I followed. So,
Oh, he's saying whether or not SELinux would block the vulnerability or not. I mean,
oh, so like some sort of thing that says, hey, we know there's this bug with X, Y, and Z, and we know that SELinux defends against that bug?
Yeah, and we published package ADC version 12 that fixes that bug. It's moderate score, available from RA10 today. But if you're running SELinux, you can wait till tomorrow.
I think sometimes we do that with we will put the SELinux analysis into a vulnerability report. Often the SELinux is more about containing the application after your application is probably going to be still vulnerable and the person might be able to take over the application, but the idea is to prevent the application from causing other harm on the system. Classic example, we had a vulnerability last year at actually the Black Hat conference, and they were reporting a vulnerability in RHEL on a hypervisor vulnerability so that a QEMU guest was able to break out and take over the system. And the report came out, and the vulnerability was fixed in the kernel before the vulnerability was published, but at the time the vulnerability was confined by SELinux, so there was no way to get by the SELinux, but you still took over
That
individual application. So it's more about controlling the applications, within the vulnerability. In some cases, we do prevent it. There's a new tool coming out that actually was developed. Well, there's a thing called SecComp, which was originally developed. I don't know who originally did it, but anyways, it's been extended by Google to allow for a Chrome to control what Chrome has a sandbox, Chromium has a sandbox application, so they can take video and all the codecs and stuff and put them in a separate process. And what they wanted to do is eliminate the syscalls that the process could call inside of the kernel to prevent it from finding a kernel vulnerability and taking over the system. So that has actually been open source now, and then we've added a library now called LibSecComp, which makes using this tool a lot easier. That should be coming out on RHEL 7. And what that allows you to do is actually, if you look at the number of syscalls that are available on a x86 64-bit box, there are approximately 650 syscalls that you can use. On a 32-bit box, you have about 325. And the reason for that is fairly obvious, that a 64 box can run 32-bit applications. So one of the things you could do is you could just fire up SecComp and say, I'm not going to run a 32-bit code inside of this application. Instantaneously, you eliminate half of the attack surface on the kernel. Similarly, there's all sorts of syscalls that almost no one would ever call that you could also eliminate from your syscalls. And that way, any vulnerability in the kernel at those levels of syscalls can be eliminated. So we're looking at, well, right now QEMU, again, for the way we launch virtual machines, has LibSecComp plugged into it, and we're starting to decrease the attack surface on the kernel. So the idea here is that a program can voluntarily go in and say, a process can go in and say, I'm never going to execute these syscalls, so please take them out of my syscall table, and then start executing the untrusted data. And now if the untrusted data actually tries to call one of those syscalls, the kernel will come back and say that syscall doesn't exist.
So
it's kind of a cool tool.
but I want to
wrap it up.
Yeah, I was gonna. I sort of figured we had like 3 minutes left. But one thing I was going to comment on though is that kind of taking the reverse approach. So you're kind of offering a lot of solutions to the problem you're describing. Personally, I strongly think that this shouldn't be a problem you have, right? In the sense that this is why automated testing, unit testing, test-driven design, all that stuff is hugely important. And really a model that your development team should be working under, particularly if they're doing web languages, right? Because the infrastructure for it is great. There's lots and lots of books about it. There's lots and lots of people who do it. You can hire people off the street who already work that way. Because when you get a vulnerability in, it should not be a big, huge process to test the application and redeploy it. It should be something you click a button and it fires up some VMs and spins up the app and runs all the tests. And yeah, it's not always going to be perfect, but it will at least you should have some strong confidence that within a couple hours you can validate whether or not this test is going to break your application, or this fix. Sorry.